Consider two planes given by their Cartesian equations. Explain why these planes are not parallel. Well, the first normal we can see is 1, -3, 3, just reading the coefficients. And the second normal is 2, 1, -1. Since the normals are not parallel, the planes cannot be parallel. State the geometric interpretation of the solution to the above simultaneous equations. Since these are two non-parallel planes, they must intersect in a line. So the planes intersect in a line. We now want to determine the vector equation for the intersection of these two planes. So if we call these equations 1 and 2, just looking at the coefficients of y and z, if I do 3 times equation 2, I'd have 6x plus 3y minus 3z equals 12. And then the other one is x minus 3y plus 3z equals 9. So if I added them, I'd get 7x. The y's and z's would disappear. And 12 and 9 is 21. That gives me that x is equal to 3. And using that, we can then turn the equations into -3y plus 3z is equal to 6, and y take away z. So if x is 3, so that would be -2. Now either of these can be used. We're going to use this one, and we are going to write that as z is equal to y plus 2. Now remember, a line can be written in the form y equals a plus lambda d, where a is going to be a point on the line, and the d is going to be the direction of the line. We know that the whole line happens in the plane x equals 3. So for the a, the x value's got to be 3. And then we can just choose a value of y or a value of z that works, or a value of y and z that works with the equations that we have. So, for example, if I use y is 0 and z is 2 together with the 3 here, that would work. And clearly there's an infinite number of solutions to that. And then we want the direction. Well, the whole thing happens in the plane x equals 3. So the x direction here must be 0. And over here, if we think about some general parameter lambda, lambda is lambda plus 2. We've already got the 2 just here. So if we do 1, 1, the y will be lambda, and the z would be lambda plus 2. So that would work with what we've got over here. Of course, I shouldn't have said lambda equals lambda plus 2. I would have let y be equal to lambda, which is what I've done, and then z would be equal to lambda plus 2. So that looks like the line of intersection of those two planes.